This is Unit 8, Video 9, Solving Equations Using Identities, Part 2. In this video, we're going to focus on not only using Pythagorean identity, which is identified here as an important identity, but also the double angle and the half angle formulas as we need to. The big thing about using a Pythagorean identity is if you see one trig function which has a square on it, and another trig function that is not squared, the first thought in your head should be, it would be great if they were all the same, but they're not. So what you need to do is you need to switch from one to the other. Now it's easiest to switch the square version. So we're going to take rid of this cosine, and we're going to make everything in terms of sine. The only way to do that is to use the Pythagorean identity. So we're going to use the sine squared plus cosine squared equal 1, and we're going to get cosine squared by itself because that's what we want to take out of the problem. So I'm going to go up here and I'm going to subtract the sine squared from both sides. And when you do that, you get the moved around Pythagorean identity of cosine squared is equal to 1 minus sine squared. So you get cosine squared x is equal to 1 minus sine squared x. So what that means is I can now change my equation, and I'm going to attempt to type it because it works so much faster. So that instead of having that, we have 1 minus sine squared x plus 4 sine x plus 4 equal to 0. The next thing you need to do is you need to move the entire equation into a quadratic format. So if you do this, you're going to have negative sine squared x for your leading term plus 4 sine x. And then you have a 1 and a 4, so that's going to be plus 5 equal to 0. Now, some of you do not like dealing with the signs in the problem, and you could do a substitution. If you do a substitution, you would let your other variable equal sine x. I'm going to continue on without doing that. It's usually easier to follow it and you'll be okay than seeing what's going on. Now, you could use either factoring or quadratic to solve for this. So what I'm going to do is I'm going to factor. Because I have a negative sine squared x, I know that I had to multiply negative sine x and something else with a positive sine x over here, and that has to equal 0. Now I want to have plus 4 in the middle, and they need to multiply to 5. If I put a 5 here and multiply, I would get negative 5 on the outside, and I would have the 1 here and would get positive 1. And that would add up to negative 5 plus 1 would give me negative 4. I don't want negative 4, I want positive 4. So I'm going to put my plus 5 here. And over here I'm going to put plus 1. Now if you see how this works, to test it you do your outers, which would be negative sine x, and your inners would be 5 sine x. And when we add them, we would get 4 sine x. Now we have our availability for tea time. So once you're here, we can tea time. And when you tea time this, over here you have negative sine x plus 5 equals 0. And we subtract 5 from both sides and get negative sine x is equal to negative 5. And divide by the negative 1, you would get, I'm going to type over the other problem for a moment, we would get sine of x is equal to 5. Now we all know that that has no solution because sine of x has to be between negative 1 and positive 1. If you have 1 sine x, it can't be up to 5. So there's no solution to this part. Over here, we know that sine of x plus 1 has to equal 0. In this step, we subtract 1 from both sides, and we get sine x is equal to negative 1. And if you recall our unit circle, where is y equal to negative 1? So in our 4 spots, we could be here, 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 or here. This is 1, 0, 0, 1, negative 1, 0. This one is 0, negative 1. And this is where the y is equal to 0. So that would mean that x here would have to be 270 degrees. There are no other locations to solve this, so there's only one answer to this question, which is x is 270 degrees, and that's our answer. Moving on to the next video, sometimes we have to do multiple to solve an incomplete quadratic and scene, and then we have to answer questions to the 10th of a degree. So we need to be careful answering this question, and there are multiple ways to solve the problem. The reason there's multiple ways is because we have this cosine double angle. And if you remember, we have 3 formulas for cosine of double angle. Now, you could pick any one of the 3. However, the one that's going to be the longest is if you substitute in cosine squared minus sine squared. That will take a lot longer than either of the other 2. So I am going to stick with the idea that we have the cosine double angle in terms of cosine. So if you go and you look at back over here, cosine double angle in terms of cosine is this 2 cosine squared minus 1. That's the one I'm going to use. So I'm going to go and plug that in. So this was 3 cosine, and instead of theta, I'm going to use x because it's just easier for me to type. 3 cosine 2x equals 2. What we want to change this to is 3 and then 2 cosine squared x minus 1, and that whole thing is going to equal 2. The next thing we have to do is distribute. So we get 6 cosine squared x minus 3 equals 2. And now we can solve this using complete the square method, or you can use quadratic formula, or you could try to see if this would be the difference of perfect squares. I'm going to use complete the square method. So I'm going to first start by adding 3 to both sides, so it's moved over. So I have cosine squared x is equal to 5. Next, I'm going to divide by 6. So I get cosine squared x is equal to 5 divided by 6. The next thing I'm going to do is I'm going to take the square root of both sides. So I got to get rid of that square. So when I do that, in my next line, I have cosine of x is equal to the square root of 5 divided by 6. So I'm just going to put the square root back in this way. Well, we are not done because we all know that this is going to be plus or minus. And we also need to figure out what is the value of the angle. Well, in order to do this, you all know that we need to do the inverse cosine. So you're going to find the inverse cosine of 5, 6. So go ahead and do that. I'm actually going to do it on a different calculator, not on my computer. And what you get is 33.557. And when you look at your results, we notice that we need the plus and the minus. That means we need 4 quadrants. So we like to go through that. I'm going to type them. In quadrant 1, that's going to be the 33.6 in terms to the nearest tenth of a degree. Quadrant 2, remember it's 180 minus 33.6. That should give us 146.4 degrees. Quadrant 3 is we're going to be adding to 180 to get our answer. And that will give us the 213.6. In quadrant 4, we're going to be subtracting from 360. And that will give us the 226.4. Now these are all degrees, so you must remember to put degree symbol on all 4 of your answers. So that's the 4 answers for this question. If you had gone through and solved with the sign, you would have gotten a different number here, but when you were solving, you would have gotten this to be x, and all four of the quadrants would be the same. So it's the only place that it's different is up until this point. After you do the inverse will give you the same reference angle. So now it says show that it does not have any solution. So that means we need to show that there are no possible answers. Well, if you look, we have multiple layers of identities going on. We've got a double angle, and then we've got a squared and a regular, and so it looks like this piece over here is a regular quadratic. This piece here is a double angle. I want you to pause the video right now and see if you can work through this question. Okay, you should have paused and worked through the question, and now I'm going to work through the question. So if you haven't done that, I'm going to use X instead of alpha just because it's easier for me to type. This should not be me spoiling any of your solutions. You should already know what this looks like. I'm just going to talk through what I'm doing. So cosine 2x is a double angle formula. I'm going to replace it with 1 minus sine squared, or this should be 1 minus 2 sine squared x from my formula sheet. And then I'll put a space there, plus 3 sine squared x minus 6 sine x equals 0. Hold on, kids are going to chaos mode. Okay, from here, From here you're going to combine like terms. So start with the squared term. Negative 2 sine squared x plus 3 sine squared x just gives us 1 sine squared x. And then we're going to just have the minus 6 sine of x, and then we combine. We've got a 1 and a 7, and that's going to give us plus 8 equal to 0. Now, if you look, this is factorable. It's sine of x minus 2 and sine of x minus 4. If you're having trouble factoring with leaving the sign in there, just pretend the sign's not there and just use x, and then go back in and resubstitute. Okay, now it's time for tea time. So when we go into tea time, over here, we have sine of x minus 2 is equal to 0. When I add the 2 to both sides, I have sine x is equal to 2. And you know that there is no solution since sine cannot be greater than 1. Sine x, I should say. And over here, on the other side of the problem, we have sine of x minus 4 equals 0. And then when we go down and add the 4 to both sides, we get sine of x is equal to 4. And there's still no solution since sine x cannot be greater than 1. So this is the showing, and then there's just a little bit of a justification just so that the person grading your paper realizes that you really do know why. Okay, this concludes this video. The next video is going to change the ideas to being more about solving graphically. So we're going to go back to some of the skills from a previous chapter, and then we're going to get into inverse trig functions in the final video.